How's it, guys? Morning. Welcome to our talk. Thanks for attending. So today we're going to be talking about how buggy mobile apps can allow their users to be tracked. So as Jason mentioned, I'm Patrick. This is my coworker, Colby. We both work at Synack. So Synack does crowdsourced vulnerability discovery. We use vetted security researchers from all over the world to basically find bugs in our customers' web apps, IoT devices, network endpoints, mobile apps, stuff like that. So our customer security is not that good, so we actually end up paying out a lot of money to our researchers. So if this is something that's of interest to you, definitely check out synack.com. All right, so today's talk can be divided into 3 parts. I'm going to start by talking about all things geolocation, at least in terms of mobile. I'm going to talk about how to do this programmatically in code, then talk about some common bug classes that we see. And then finally, we're going to look at some actual applications that had geolocation vulnerabilities. Then I'm going to turn it over to Colby. Colby's going to walk us through kind of a case study of a very popular app that had a myriad of geolocation vulnerabilities that we discovered that cumulatively allowed us to track any of its users anywhere, anytime in the world. And then we're going to finish up with some fixes and conclusions, best practices. All right, so first, an overview of geolocation, some code, and some interesting bugs. So first, you might be thinking, why are we even talking about geolocation in mobile apps? Well, it turns out that integrating geolocation capabilities into mobile apps is almost the norm. And about 3/4 of smartphone users actually make use of geolocation in some way, shape, or form on their devices. So here's some categories of mobile apps that make use of geolocation. So first, social. Obviously, Facebook, Twitter, Instagram. You can upload photos, tag where they were taken, check in. That's geolocation. Recommendations. You're at ShakaCon. You want to use Yelp to figure out what's good around. Again, that uses geolocation. It's going to send your current location to Yelp, and then Yelp's going to give you information about what's nearby. Health and fitness. Something like Runkeeper tracks where you've run, and you can share that online. Again, that's geolocation. Navigation, obviously, point A to point B. And then finally, we're seeing even apps that are related to commerce or banking providing geolocation capabilities. So a store's app might detect when you're nearby one of their stores and give you a little pop-up with a coupon or a sale information. All right, so before we go off hunting bugs, I thought it'd be important to understand how geolocation is implemented in apps at the code level. So today we're only going to be talking about iOS. So on iOS, there's 4 or 5 basic steps that you should perform in order to do geolocation in an app. And it all revolves around the CL location manager. This is the framework, the API that you talk to in order to do geolocation. So the first step is you create an instance of the CL location manager. Once you have an instance of the object, you set a delegate. A delegate is simply a method or an object that will get automatically invoked by the operating system when there is an OS geolocation update. So basically, you have to tell the operating system what object or what method you want it to call back. You then you tell the operating system, hey, I'm ready to go, start delivering these geolocation updates. And then you basically wait, and when there is an OS geolocation update, for example, when the device moves, the iOS will automatically call your delegate, and you can process the function. So this is how it looks like in code. So this is a Swift app that shows how to grab the user's current location. So we can see the steps I just described. Step 1, we can see that we're creating an instance of the CL location manager. Step 2, we're setting the delegate. We're setting it to ourself. Again, it just said when there's a geolocation update, please iOS call us back because we're interested in it. Step 3, we tell the operating system we're ready to go, so start collecting. And then at the bottom, that's step 4, that's the delegate. So this is the function, the method, that's going to get called by the operating system. So when we run this, compile this, we'll see we get an app that's able to access the user's location. Now, there's one thing I skipped over, and that's the thing that's circled in the black box, and this is requesting authorization. So this makes sense, but apps have to explicitly request authorization to access the user's location. Obviously, geolocation is something that's sensitive. There might be some security things involved with it. So apps can't just blindly access that without the user's permission. So on iOS, there's 2 ways to gain access to this. And it depends on what kind of access you want. So the first one is for applications that want access to the user or the device's location only while the application is in use. So while it's in the foreground, while the app is being interacted by with the user. So in order to request this kind of authentication, 2 steps. You set the NS location when in use usage key in the app's plist file, and then at runtime you invoke the request when in use authorization method. If you do this, you'll get that OS level pop-up you can see on the slide that basically allows the user to confirm or deny. So if they deny this, the application will not be able to access geolocation information. If they do allow it, the app will be able to, but only when the app is foreground. So if the user backgrounds the app, it will no longer be able to access that. The second way allows applications to access the user's or the device's geolocation information at all times. Now, this makes sense for things like navigation apps. So you think about it, you put in point A, point B, you click go, you then switch to Facebook, and you're texting while you're driving or something. Obviously, the app in the background, the navigation app, still needs to know your location so that when you come into like a fork in a road, it can tell you to take it. So in this case, you basically do something similar. You request authorization at all times. So basically, you invoke the request always authorization method. And at this point, you get a similar OS level pop-up. Again, the user can click confirm or deny. All right, so as I mentioned, geolocation apps is pretty much the norm. And it's a really cool feature. I mean, it's one of the features that make our smartphones smart. The problem is if the applications are buggy, the user's location can leak. Now, this is really bad from the user's point of view for privacy and security reasons. But the bad guys, rather, actually like this and have made use of this. So you might be thinking, I don't really care if someone, the government, criminal, knows my current location. I surf, I go to work, walk the dog. I'm not a terrorist drug dealer. But it turns out that by simply knowing someone's location, you can actually build a really good dossier of their entire life. So there's this quote I like that articulates this really well. So this quote says that geolocation creates a precise, comprehensive record of a person's public movements that reflect a wealth of detail about her familial, political, professional, religious, and sexual associations. So again, just from knowing someone's location, where they're at day to day, and being able to track them, you can build a ton of information about them, which probably can be used against you in some form, maybe to blackmail you, or if you're in a difficult situation, maybe coerce you, use it against you. Now, there's even simpler scenarios where there have been cases where criminals have used people's geolocation information to rob their house. So we're all here in Hawaii. We're probably jumping on Facebook, Twitter, telling all our friends back on the mainland how awesome it is, tweeting that kind of stuff, maybe tagging some photos. And if a criminal can see this information, if this information is public, and they wanted to rob our houses, now would be a really good time because we're out of the state. All right, so now I'm going to talk about some common classes of bugs in mobile apps that may reveal users' locations, and then also how to find such bugs. So in the subsequent slides, we're going to cover each of these categories. All right, so first I want to talk about insecure network communications. So if an app doesn't secure its network information communications and sensitive information such as geolocation is transmitted, a remote passive attacker may be able to sniff and therefore access this information. So this obviously, from a user point of view, again, not ideal. So applications should not use unencrypted comms. They should not allow self-signed certificates. And they should also make use of something called SSL certificate pinning. So the easiest way to find these kind of bugs, to look for insecure network comms, is to simply sniff the network traffic. This turns out it's actually pretty easy to do. So what you do is you first set up a proxy on your host device, on your laptop. There's a variety of free ones. I use Burp. It requires Java, which kind of sucks, but other than that, it's free and pretty decent. So once you have this set up, you then hop onto your device and configure it to talk to the proxy. So you first install the proxy's SSL certificate on the device so that it's trusted. And then you go into the Wi-Fi settings and set the IP address and the port of the proxy. Then you also turn off cell comms. So from now on, anytime you fire up an app on your device, it's going to be automatically routed through the proxy, and you can examine all network traffic. So one thing we see, and this is one of the things I always look for first, is just are the comms secured? Are there any connections that are not SSL? And a lot of times what we see is that the main comms between the app and the app's servers in the cloud, those are usually secured. Those are usually over HTTPS. But a lot of times apps will talk to third-party services, so diagnostic services, logging services. And a lot of times these connections will not be secure. So if there's geolocation information in those that traffic, again, an attacker may be able to sniff that and figure out the user's location. So this is pretty easy to detect at the proxy level. You pretty much just filter out all the HTTPS traffic, look what's left, and this will be the insecure traffic, and then see, are there any geolocation coordinates being transmitted? Like I said, we see this all the time. So another good thing to look for is to determine if the application accepts self-signed certificates. Obviously, if the app does accept self-signed certificates, this means that an hacker will be able to man in the middle of the attack, even if it's over SSL, just providing their own certificate. So here you can look. This is some disassembly from an app that did allow self-signed certificates. And we can see that it's invoking the set always allow HTTPS certificate for host. Now, iOS by default doesn't allow applications to allow self-signed certificates, which is a good thing. But developers can override this functionality by invoking this method. So again, I'm not sure if developers do this while they're testing and then this leaks into production code, but we have seen apps where there is this code and the application was therefore vulnerable to a man-in-the-middle attack. And again, if then geolocation information is being transmitted, an attacker could man in the middle of this, these connections and then figure out where the user is. So another thing in terms of insecure network communication is, did the app forget to pin its SSL certificates? So SSL pinning is a layer of security that protects against rogue CAs or social engineering attacks. So if an application does not use SSL pinning, the following scenario could allow a hacker to man in the middle a connection. So the goal here is for the hacker to get their malicious, untrusted certificate installed onto the user's device, the user that they're targeting. So it turns out iOS is actually pretty easy because iOS detects certificates in emails and allows you to click on them, and it'll give you a warning, but if you click yes, it'll then install them into the device. So you can imagine a hacker maybe emailing an employee on the first day of work saying, hey, in order to use your iPhone at work, please install this certificate. Some users are going to click on this, right? So at this point, if they do that, the attacker's certificate will be now installed on the device, and if the application is not using SSL pinning, the attacker's certificate will be able to man in the middle of the connection. If the application is using SSL pinning, it doesn't even look at the installed certs. It basically says, I'm only going to talk to one cert, which is the application server. So even if the hacker gets that installed, it doesn't impact the communications. They'll still be secured. So the easiest way to find this is to see basically if your app connects to the proxy and talks to this. Because remember, we installed the proxy certificate on the device. So that's almost the same scenario as a hacker installing a third-party certificate on the device. So if the app is using pinning, it won't like that proxy certificate and will refuse to talk to the proxy over SSL. So again, not a very high-tech way to figure out if the app is pinning, but a good way to kind of make sure of that. Now, there are tools if you have a jailbroken device to override the pinning. For example, if you want to do some analysis of the traffic. So that's kind of a good thing to be aware of as well. All right, so the next thing I want to talk about is insecure local storage. So the unfortunate reality is a lot of phones get lost or stolen. And if there's sensitive information, such as geolocation coordinates that are stored insecurely, if your phone is lost or stolen, an attacker may be able to access and figure out where you've been, where you go, all that sort of stuff. So unfortunately, we see a lot of apps that store sensitive information like geolocation coordinates in insecure files,plists and databases, and sometimes even in log files. So the simplest way to determine if an app is vulnerable to this kind of attack is to simply run a tool such as FileMon and then another tool such as FileDP. So FileMon, like its name suggests, will monitor file I/O activity. So what you can do is you run this on a jailbroken device, fire up the app, and then basically watch what files the app is creating. Here we can see the Where's Waldo app is creating a location.db file, and then also a last known location.plist. So these are the kind of files you probably just want to open up and see, is there sensitive information? Is there geolocation coordinates that are in these files? So once you find an interesting file, or file with some interesting data, you basically want to check its file attributes. So on older versions of iOS, sure, all files are encrypted when the device is shut off. But if the device is turned on, these files are automatically decrypted by the OS, even without the user's passcode. So this means that if the attacker gets your phone and can boot it and access the file system, they don't even need your passcode PIN to access these files. So Apple provided a second layer of encryption that's based off the passcode or the PIN code of your device. And this should be used because this basically means that an attacker now has to guess or brute force your passcode in order to decrypt these files. So you want to look to see if the files containing this sensitive information contain this specific attribute or make use of this second layer of encryption, which is opt-in. So what you can do is you basically look for a file attribute called NS file protection key. And if it's missing, that means the file is insecure. Or if the key is there but set to NS protection none, again, this means that the file will be automatically decrypted by the operating system whenever the device is powered on, even without the passcode entered. So one place I always look for such insecurely stored data is in the user's default. So iOS has the notion of user's default, which is an easy way for applications to store user preferences. So if you look at the disassembly on the slide, you can basically see we're setting a geo info preference. Now, if you notice here, there's no file I/O APIs. You don't have to open a file. You don't have to write bytes out. You don't have to close, flush the file. So what iOS has done is abstracted all this away. So you basically set a key in a dictionary, and it takes care of all the file I/O. So since this is such an easy thing to use, a lot of developers misuse it and store sensitive information here. Again, it's only supposed to be storing users' preferences, like what color they want the background in the app or what their time preference is. You should not be storing sensitive information like geolocation information here. So I always go and look at this file and say, are there any sensitive information in here? Because this file is not encrypted. So if your phone is lost, any information in this file will be accessible to an attacker. All right, so now I want to talk about location spoofing. Now, the key thing here is that developers should not trust data from the client about their location, because this is trivial to spoof. So developers on the server side should specifically not use the client's location or their location to say things like, I will let you authorize. So we see some apps that maybe only let users log in from while they're at work in some geo-fenced area or from their home state or hometown. If it's maybe a banking app with some extra layer of security. Now, if you can spoof this location, that gives no extra level of security. Also, we see a lot of apps that give access to relative data that's sensitive. So obviously, if you can spoof and change that location, you can gather tons of relative data. Applications on the server side should also not allow applications to rapidly change their location, because this is probably something a hacker is going to do to perform an attack. So this allows for harvesting of data. So if there's an app that provides, say a dating app that provides information about people who are nearby you, and you can change that location, you can now gather information about everyone on that platform. Similarly, and Colby will talk about this, if you change your location, you can actually perform a trilateration attack to find out people's exact location, even if the app only provides you relative location. Like it says, someone's within a quarter mile from you, but doesn't tell you exactly where they are. You can use this to figure out exactly where they are. Now, the easiest way to figure out if the app is vulnerable to geolocation is just to change your location and see what it gives you. So there's a variety of ways to do this. If you have a jailbroken device, you can use, there's some Cydia apps that will globally change the iPhone's or the device's location. If you can, also, if you have a jailbroken device, you can use a tool which is called Script, which will allow you to inject code into the application at runtime and manipulate the location as well. I find the easiest way is just to look at the network request that's going out and change the geolocation coordinates and see how the server-side component of the app responds. So think about it, a dating app, let's start in Russia. It's going to send our location, and it's probably going to give us back matches that look Russian. Then if we spoof this location and say, OK, now we're in Hawaii, it's probably going to give us back people who surf and do yoga. So very easily you can tell, OK, my spoofing basically worked. So again, not super high tech, but pretty easy way to figure out if your spoofing basically worked. So another thing I want to talk about is overly precise location. Now, this isn't a bug per se, but if geolocation coordinates are being leaked or accessible via another bug, knowing exactly where the user is a lot worse. So think about it this way. If geolocation coordinates are being leaked, but the accuracy is only within 1 or 2 miles, that's not that bad. Whereas if geolocation coordinates are down to the foot level or within 10 feet, that's a lot worse, because then you know exactly where the user is at. So the main reason we see this in applications is because by default, iOS provides you the highest level of accuracy possible if you don't specify what level you want. So how can you determine if an application is using overly precise geolocation? Again, the easiest way to sniff the network traffic, the geolocation coordinates that are being sent up to the server, just grab those and plug them into Google Maps, and then see, if you're doing this from your house, does it plot you within your neighborhood? Does it plot you within your house? Does it plot you within the room of your house? So that's a really good way to figure out how accurate they are. You can also look at the disassembly and look for the set desired accuracy method. So this allows you to specify what level of accuracy you want or what the application wants. So its third argument of this method is the accuracy constant. And if this is set to CL location accuracy best, this means the app is saying, hey, iOS, please give me the most accurate geolocation information you have because I want to make use of that. And remember, if it's not specified, that call is not made, iOS is going to default to the highest level. All right, another common bug class we see a lot that can reveal users' locations are buggy server-side APIs. So we see a lot of apps that assume that if their API endpoint is not documented, no one is going to poke on it and hack on it. They also assume that rate limiting is not needed. They assume that only applications on devices are going to be talking to this API. We coded those applications. We know those are well-behaved, so we don't need to do any rate limited. If they don't do rate limited, obviously you can harvest a ton of data. Similarly, a lot of these APIs allow completely anonymous queries. So again, you can just, as an attacker, connect and ask the API, and it'll just give you all sorts of information. A lot of times we see a lot of sensitive geolocation information. And in Colby's case study, he'll talk a little bit more about this. So again, the easiest way to find these kinds of vulnerabilities is just to look at the network traffic and see what API endpoints is the application talking to. And then grab those and start poking around on them. From the network requests, you can see probably what parameters it takes, so you can fuzz those, change those up. So here we can see an example. There is an application that is talking to a where am I API endpoint. And it takes your username and gives you back your known location. So what you can do is you can change the username and see if it gives you back information about other users. So again, in this example, we change it from Waldo to Carmen San Diego, and then the application gives us back the location of Carmen San Diego. All right, so the last class of geolocation vulnerabilities I want to talk about deals with the UI. So it's funny, or I guess more sad, but a lot of developers, again, assume that no one is going to poke around under the UI or try to manipulate the UI for malicious purposes. So we see a lot of bugs that have this kind of issue. So one issue we see a lot is there will be a UI setting that the user can select, but this setting is not really respected at the app level. So we've seen apps where the user can turn off sharing within the app. But we still see then the app send the location data to the server, which is kind of counterintuitive. A lot of times what I think is occurring is that the server-side component is not going to share their location with other users. But if the geolocation information between the app and the server is insecure, even if the user says, don't share my location, it's still being shared. So someone might be able to sniff it. And also, do you really trust that app developer? Once they have your geolocation information, they might do something malicious with that. Another UI issue we see is that logic that should be implemented on the server side is implemented at the UI level. So again, think of a dating app that allows you to specify the level of accuracy that you're OK sharing your location with. Obviously, you probably want to share your location so that you can find matches, people nearby. But you might not want them knowing exactly where you're at. So you say, OK, I'm OK if they know where I'm at within a mile, but I don't want this down to the sub 5, 10 feet type of thing. So you set this setting. And we've seen cases where your exact geolocation information is still sent to the server. And then the server sends your exact location to other users. And then the instances of the app on the other users' devices are what are doing the rounding. So they basically say, oh, this person says, I only want to share within a mile. So to user B, they do the rounding and then only show it there. Obviously, again, if the comms are insecure between the original app and the server, someone could sniff this and get your exact location, even though you said, I only want to share it within a 10-mile radius. And worse, since the server is then sending your exact geolocation coordinates to other instances of the app and expecting the app to do the rounding there, if you're an attacker and can talk to those APIs directly, you're going to get users' exact location, even though they requested not to. All right, so let's talk about some real-life examples. So here's some apps that were or still are vulnerable to a variety of geolocation vulnerabilities. So the first is Starbucks. Now this is kind of interesting because you're like, why is Starbucks tracking me, right? This kind of just shows that geolocation is everywhere. Unfortunately, older versions of the Starbucks app had a vulnerability where users' geolocation coordinates were stored in an unencrypted file. Again, this means if the phone was lost or stolen, an attacker would be able to access users' location. Now, this isn't the worst bug. I mean, they'll probably just figure out when and where you go to Starbucks. But again, shows you that even apps like Starbucks might be tracking you and then storing your geolocation insecurely. This one's a little worse. So Whisper was a secret sharing app. Basically allowed users to anonymously whisper or post secrets online. It had a UI bug or feature that even if the user opted out of sharing their location, their information would still get sent to the server, including their exact location. Now, this wouldn't be sent on to other users, but it was still being sent to the developers in the cloud. So there was a report on this because the Guardian found out that the application developers were actually sharing this geolocation information with the government, with the DoD. So this is a screenshot from the report. This is from Fort Meade, NSA. So you can see there's a ton of Whisper users, and their locations were being sent to the app developers and also then shared with the DoD, even though the users had requested to opt out. Now, maybe this scenario, if people are whispering about stuff in the NSA, the government might want to know about this. I'm not going to pass judgment there, but this indicates, again, that the app was not respecting the UI settings, and geolocation information was being leaked and then shared with other parties. Yes, and the drone. Another example was Tinder, again, super popular dating app. Back in the day, it had a really bad issue where it would give you the exact location of all the users of that app within your location. So you could track everyone indiscriminately. They then updated this to provide only relative distances. So they would say, OK, here are your matches, or here are the Tinder users, and they're within a mile of you or a quarter mile of you. So they thought, hey, that doesn't give someone enough information to figure out where they could be, because they could be a mile in any direction. Well, it turned out you could still spoof your location, so you could perform a trilateration attack, which Colby will talk about more, that basically allow you to spoof your location 3 times, and then mathematically you could figure out the exact location of the user. There are other issues as well related to privacy, where since you had to use sign in with Facebook to access Tinder, there was some information that tied Tinder users to their Facebook accounts if you analyze the network traffic. So again, this is problematic because a lot of people share a lot more information on their Facebook profile. So now you can tie their Tinder profile to their Facebook profile. A lot of times there's phone numbers, addresses, just a lot more information. So this was all reported to Tinder. They patched and fixed everything, but not before applications may or may not have been created that would allow you to log in with your Tinder information and then see all Tinder users in your location on a map down to the sub 5, 10-foot region. So again, this meant that any Tinder user could be tracked indiscriminately. All right, so the last app I want to talk about is Angry Birds. Again, this is kind of like the Starbucks app. It's kind of interesting because you don't think this app would be, 1, collecting your information, and then 2, leaking it. But it turns out that it was. And again, a report from The Guardian illustrated that some leaked documents indicated that government agencies were actually targeting this specific app because it did leak geolocation information, and were using this to track users of interest. So I think this really hits home the fact that any app, even stupid app that you play while on the bathroom, can be collecting your information, and then if it is transmitting it insecurely, like in this case it was, the government will be watching, or maybe watching. So, not to scare anyone, but it just again reiterates the fact that geolocation, is really sensitive, and there are people out there who are trying to collect it. All right, so Colby now is going to talk about an app that was vulnerable to a myriad of geolocation vulnerabilities, kind of a lot of the classes I just talked about, that cumulatively allowed us to track any of its users anytime, anywhere in the world.
Awesome. Thanks, Patrick. So we've talked about how these location vulnerabilities occur, but what are the real-world implications? So we surveyed a lot of applications out there and decided that one called GRINDR was the ideal candidate due to its ridiculously bad use of geo information. So what is GRINDR? According to their website, it's the largest and most popular all-male location-based social network out there. More than 5 million guys in 192 countries around the world, and approximately 10,000 more new users downloading the app every day. Bottom line, the app is based completely around knowing who's near you. It's extremely popular, and it caters to a demographic that has a history of being targeted. So we figured it'd be a good idea to take a look from a user privacy standpoint. So to begin our assessment, we checked to see if there were any previous vulnerabilities publicized, and sure enough, there was. A while back, in 2012, a vulnerability was discovered that allowed impersonation of users, as well as sensitive data compromise. 2013, a graduate school paper revealed more concerns around user enumeration, impersonation, and identification. Recently, we published our assessment, which was the first to bring up the issue of location privacy, and we'll talk about that more in a minute. And then eventually down the road, after all of this, someone else caught on and leaked a similar vulnerability to pastebin, which we'll also talk about more in a minute. So what did the developers do wrong? What could they have done better? There's no SSL pinning at all in the application, so a man-in-the-middle attack is easy enough. Geo is provided with way, way, way too much accuracy, really down to the foot level. Location spoofing to the server was trivial. They didn't do any filtering. And the APIs were overly permissive. Really no authentication, nothing like that. And then all data was filtered on the UI level as well. So basically everything we just talked about. So the first bug, we noticed that the iOS application doesn't pin SSL certs. And so as Patrick talked about earlier, this makes it much easier for an attacker to pull off a man-in-the-middle attack and to sniff credentials, as we show here in the screenshot. So using a man-in-the-middle proxy, we're able to take advantage of this lack of SSL pinning to examine the application's protocol and reverse engineer it in order to build our own custom GRINDR client. Bug number 2. Upon running the app, it queries the server and pulls down a series of JSON blobs for every single user nearby. And in each blob is the user's profile information. The problem here is that the distance field provides us with extremely precise relative distance. The distance shown here is in kilometers, and it's down to the sub-centimeter level, I guess. This opens up the possibility of the trilateration attack. So we reported these bugs to GRINDR a while back, and they made some changes. Unfortunately, the changes had little effect. Looking at the disassembly of the newest iOS app, we can see the location accuracy is set to 10 meters of precision. The problem with this is that A, 10 meters of precision is still enough to identify where someone lives, works, whatever. And with this setting, you're guaranteed that the result is within 10 meters, not 10 meters of error. So we found that it generally represents about 3 meters of precision, which is still pretty good. So it would have been nice if some of these mobile apps had introduced some random error to kind of add some jitter, add some uncertainty into the results. So this image here is showing Patrick testing the app in his office, and the location was within about 3 feet. So one of the bigger problems that we saw was that the API would accept arbitrary coordinates from an unauthorized user. So basically, we could say we were here in Hawaii 1 minute, in Africa the next, and literally make dozens of queries per second. So there's no rate limiting or distance limiting on the changes, and so that opened up, again, the possibility of trilateration. So furthermore, no authentication was required to talk to GRINDR's APIs, really none at all. And the amount of queries weren't limited. It was pretty much a dream for someone who wanted to scrape a ton of data really, really fast. And using this, it became trivial to enumerate users and pull down everyone's profile info containing name, height, weight, age, relative distance, and social media links and profiles. So GRINDR has since implemented authentication. However, signing up for an account takes just seconds, and there's no email confirmation. And so bypassing this really is completely trivial. So while examining the JSON data from other users, we found something, I guess, kind of odd. There was a key titled show distance. And sometimes this key was set to false, but distances were still in the JSON data. So it turns out that the UI on the phone was what was doing the filtering to decide whether or not to display this location data. So in short, data was being broadcasted to everyone, just not displayed. And with a little bit of technical savviness, it wasn't hard to view it. So here you can see essentially how the setting was implemented in the application. So we have all these seemingly minor vulnerabilities in the app. But what could a real-world attacker do with this data? So we decided to write a framework that leveraged these bugs to find out for ourselves. How much trouble could we get into? Before we go any further, I should note that the purpose of this research was not to identify GRINDR users, but to help protect those that wish to remain private. And that during the vulnerability research and disclosure, no unwilling users were intentionally or unintentionally identified, and that all data we logged during this has been irrecoverably destroyed. So based on the bugs we found, we theorized that we should be able to track any user at any given time. The APIs were wide open. We had extremely precise geolocation information, and location spoofing was dead easy. So how does our framework do it? First, we need to engineer the data gathering component of the interfaces in the API. Basically, just scrape all the data out there. So based on location, we can download and parse specific data for nearby users. And we're specifically interested in getting that distance parameter for the different users. So now that we're able to suck down the user information and determine what users are nearby, we needed a way to locate them. And this is where the trilateration comes into play. To do this, we gather distances and implement the trilateration algorithm. In short, trilateration is the method of determining an absolute location based on 3 or more relative distances. So first, we spoof our location 3 times around a location of interest, like let's just say around the island here. And then we query a specific user's relative location from each point. And then due to the Earth being a sphere, distances are measured along the circumference. So we have to convert these distances we receive accordingly. We map them to a spherical coordinate system and do that before we run any calculations. Ultimately, after a lot of math, which I'd be happy to provide some code or go through if you guys want to try this at home, we're able to determine a user's actual standardized coordinates. So now that we have a way to determine location, let's run it on a massive scale and map some users. So here are screenshots from our mappings early last year. Shown is San Francisco and the Sochi Olympics. So just as a sanity check, you can see that all users fall within the land masses and tend to be in densely populated areas. And this brings up some really interesting privacy issues, especially for prominent figures that may be GRINDR users. What if you're an athlete at the Sochi Olympics or a politician or a movie star or and you're trying to use GRINDR to date anonymously? You might not want the media or public to be involved in that side of your life, especially if you wish for your sexual preferences to remain private. It's very conceivable to think that someone could watch a specific location, such as maybe a US Capitol, the White House, to determine specific users' identities, to determine their identities for malicious purposes. But we'll talk more about that in a minute. So to test our theory, we tracked some willing users over the time span of a week. And sure enough, a lot of patterns emerged. More often than not, we observed that for each user, there were dozens of data points, but they tended to map to 2 different locations. And those tended to be their home and work locations. And occasionally, you'd see pit stops that looked like a gym or the grocery store. So in these screenshots here, you can see the kind of accuracy we're getting. I mean, really falling within someone's house or location. Really, you could get a pretty good idea of where they were. So let's take it one step further. We know we can track you, or some random person, but who are you? So first we have the geolocation information, which tends to be scary accurate. But let's combine that with public record sources, such as home ownership databases for home locations, and LinkedIn profiles for work locations. And it becomes really easy to guess who works and lives in a specific area. So to validate these identities, GRINDR users tend to share a lot of personal info, including name, photos, age, height, weight, et cetera. Not to mention, a lot of users tend to share social media profiles as well in their GRINDR profiles. So we conducted tests using this method on several willing participants, had nearly 100% success rate in determining their identities of who they were. So even if you wish to remain anonymous, which a lot of GRINDR users do, this method could still be used to reveal their identity. So as I mentioned earlier, what if you're a public figure using GRINDR? How at risk are you? We were approached a while back by a US government official who does OPSEC for the Senate. And he was concerned for our various representatives. And he thought they needed to hear this information for any social media and sharing app they were looking at. And sure enough, he was right. Most recently, an anti-gay North Dakota representative was found to be a GRINDR user, and as well as a married anti-gay pastor who ended up resigning over the scandal. And they were exposed as GRINDR users. So really, it's conceivable to think that someone politically motivated could use these techniques to further their agenda and damage someone's reputation. I mean, it sounds like it's straight out of House of Cards. But really, I mean, someone would kill over this stuff. So we disclosed to GRINDR and stressed the urgency of these vulnerabilities. We've even provided a write-up, POCs, but in the end, they refused to fix anything. And to quote them, "We do not view this as a security flaw." So we kept silent, and we waited for a fix and kept urging them to fix it. But ultimately, as with all bugs, someone found it. An anonymous hacker posted a POC to Pastebin a while ago titled, "GRINDR fails to protect their users." And it demoed how you could use the same functionality to track users through GRINDR. Fast forward a couple days, and it turns out that Egyptian officials began using this bug to track down and arrest gay men, since it's illegal to be gay in Egypt. So we see security bugs every day, and sometimes it's hard to imagine that there's an actual real-world impact that people could get hurt. And to see something like this, it really drives that point home why some of these seemingly minor bugs are actually quite serious. So after all the bad news and social pressure, GRINDR decided to try their hand at a fix. User settings for sharing location and data within the app are now respected. Geofencing has been implemented in Egypt and other countries where it's illegal to be gay to prevent location sharing from working. Authentication is now required, and they've set their GPS accuracy to the nearest 10 meters. But as our most recent tests indicated, the SSL pinning issue still needs to be fixed. The APIs employ almost zero security or rate limiting, and spoofing locations is still possible. Realistically, you can still all do this on some level in certain areas. So yeah, end result, you can track users with decent accuracy and still likely find out their identities. All right, so as a location-aware app developer, what can you do to not fall into this trap? And for your users, what can you do to protect yourself? Users, you really just need to assume you can be tracked. Accept that risk and act accordingly. If you're really paranoid, drill down into your location preferences in your phone and turn off location sharing for apps or for any specific apps at the OS level. That's really the only way to guarantee your privacy. Developers really do everything that Patrick talked about. Use secure communication and do it right. There's no reason not to. Protect your APIs. Think of the edge cases. Think of the abuse cases. Use correct UI level logic. Don't do your filtering there. Try to do it all server-side. Use secure local storage. Really not that hard. And don't share any more precise geolocation information than you need to. So thanks, guys, for coming out. I really appreciate you attending our talk. We can do questions and comments. And afterwards, we have a booth over there, our Synack booth. We're giving away a free parasailing trip. So if you guys want to enter for that, drop by and take a stab at it. But yeah, thank you. Questions, comments? Yeah, right in the back.
Yeah, so I think conceptually a lot of the same things still apply, like the insecure storage or securing the comms. I don't do a lot of Android dev, so I don't know exactly how that all works. But again, I would start by sniffing the network traffic, see are geolocations coordinates being sent insecurely, or what happens if you change them? Can you spoof your location? So I would guess that there's similarly functionally equivalent kind of vulnerabilities, but I think it's something that should definitely be looked at. Like the GRINDR case, a lot of the issues were in the server-side APIs where anyone can connect to them. So that's a vulnerability that iOS or agnostic Android kind of stuff. So.
Yep. Yeah, the Android app we looked at, it talks to the exact same APIs, and really that's where the bulk of the vulnerability lies.
Yep, right here.
You made a comment to turn off your location in certain apps. You can't. I haven't seen a lot of apps where they actually give you that level of granularity without losing a lot of the functionality. Are there any apps that you know of that are out there that would allow you, third-party apps, to control more of the location information that's being stored in your phone, possibly securely delete it, things like that?
I'm not sure of any. Exactly like you said, if you don't want to share your location, the best way is to go into the iOS settings, the OS level settings, and turn off location sharing for that app, because then the app can't access that. But then, like you said, a lot of apps that use geolocation kind of become useless. So unfortunately, there's not this kind of level where you can kind of pick and choose. And even the apps that might let you do that, as we showed a lot of bugs, they'll still send your really precise information to this.
If you have a jailbroken phone, I think there's a couple apps out there that will let you spoof your GPS location. And so you could manually set that and just have to know how that relates to the app and hopefully still use some of the functionality.
And then hope you don't get hacked because you have a jailbroken phone.
Yeah.
Hacking team.
Yeah.
Yes?
So Apple has a vetting process, theoretically, for apps. With some of these discoveries, have they said anything about what they're looking for?
Sure. So we talked. The question was, does Apple when they vet your app, does this stuff come up? Are they looking for this stuff? So we talked a little bit to Apple, and it finds out that they pretty much only care, are you using legitimate APIs? Are you not willingly trying to do something malicious? So these are all more like developer shortcomings. Some people would argue they're even features. So Apple doesn't really care about them because it's pretty much functionality that's built into the app, and they're not really in the business of looking at for code level vulnerabilities. They're basically making sure, do you adhere to their guidelines?
Yeah.
So
we see all these apps out here that are, most all apps are using your location some way or another. So it's really up to you to, pick and choose who you actually trust. Do you trust the random app developer to do something right? Probably not.
Probably shouldn't trust anybody.
Yeah, well, yeah.
Any other questions? Awesome, guys. Well, hopefully see you all again next year.
Yeah, thanks a lot. All right.